Hey guys, Jake here, coming at you with another math lesson today. Today we're going to continue our discussion of how to find derivatives of certain elementary functions from my book, The Elite Guide to AP Calculus AB. Yesterday we talked about how to find the derivative of logarithmic functions. Today we're going to be discussing how to find the derivative of exponential functions. So it's going to actually play out pretty similarly to the example we did in yesterday's video, but I wanted to show you a couple examples of exponential functions and how to find their derivatives. So let's go ahead and just jump right into it. We're going to find the derivatives of the following functions. F of x equals 4 times e to the x, and then g of x, which is 3 times 5 to the x. So these are, again, very elementary versions of exponential functions. There are obviously more complicated exponential functions that you might need to find the derivative of that starts getting into other things, product rule, chain rule, quotient rule, more complex exponential functions with other kind of pieces to them. We're just starting here with kind of the more elementary version. We'll get into some of those more complex derivatives at some point in the future, but just wanted to start with these for now. So very similar to yesterday's example with the logarithmic functions, we are pretty much just going to be applying a formula to find the derivative of each of these. So let's start with this first one here, f of x, which is 4 times e to the x. You want to remember that the derivative with respect to x of e to the x is just simply e to the x. It's actually the only non-zero function whose derivative is itself. So kind of a nice function to be taking the derivative of. In this case, our f of x is a constant number 4 times e to the x, though. So it's going to be, one other kind of piece there to think about, which is this constant out front, our constant coefficient. So in general, I actually just talked about this in yesterday's video too. If you have some constant coefficient times some function, and you're trying to take the derivative of this whole thing, you're essentially just going to carry that constant coefficient through as a constant coefficient in the derivative as well. So the derivative of a constant 4 times this other kind of function e to the x here, function of x, function of your variable, you're just going to basically carry that 4 through into your derivative as well. So you're just going to have a constant coefficient 4 again, and it's going to be multiplied by the derivative of whatever e to the x is. Well, like we just said here, the derivative of e to the x is just e to the x. So our derivative of 4e to the x is just simply going to be 4 times e to the x. Kind of a unique situation where, the derivative is just the same as the original function. So let's go into this example now. We're going to find the derivative of g of x, which is 3 times 5 to the x. So this is going to be just a little bit more complicated. Not much, to be honest. We have a very similar setup here where we have this constant coefficient in front times some function of x, where we have a constant base and then a variable x as our exponent. Very similar setup to what we had over here, where we had our constant coefficient, we had a constant base of e. I know it's weird that this e is a constant, but e is like pi. It represents a very specific known number. It's like 2.71 something. It goes on forever. It's an infinite decimal, but it's a constant. It's just a number, 2.7 roughly. So we, again, just had a constant base times x. Well, e being the base made this situation a little bit unique because the derivative of e to the x is just e to the x. But if you have the derivative of some other unknown constant, let's call it a, so we'll say the derivative of a to the x, where a is a constant, any constant, the derivative of that would just be a to the x times natural log of a. So this formula does still actually work correctly, even if a is e. So if this constant e, 2.71, is the base here, this formula still works. And the reason for that is because we would still get e to the x, and then we would multiply it by natural log of e. Well, natural log of e is just 1. So you would essentially just get e to the x times 1, which is just e to the x. So this formula right here is kind of a shortcut when you have that specific situation where e is your base. When your base is any other constant, you can just use this formula instead, which is obviously a tiny bit more complex because we have this natural log of a piece here, but it's really not that much different, not much harder. So essentially, to find the derivative here, g prime of x, all we need to do is, again, we have this constant coefficient of 3 out front. We can just carry straight through to our derivative. So we're just going to have 3 times, and then for the 5 to the x component, we can just use this formula here. We're just going to say a is 5, our x is obviously x, and we can just apply this formula. So we're just going to get 5 to the x times natural log of 5. And we could kind of rearrange these so that we have all of our constants out to the left. So 3 natural log of 5 times 5 to the x. But this would essentially just be your derivative, g prime. So in the coming weeks, we're going to continue going through additional topics and problems from the Elite Guide to AP Calculus AB. If you want to check that book out, go scan the QR code in the top of your screen or check out the link in the pinned comment below or in the description. And be sure to come back for the next video, and we'll keep going through topics and getting you prepped for the AP Calc AB test. So thanks, and see you next time.